Hello everyone. So in this video we are going to solve a question that is changing a binary tree to the doubly linked list. So we have given a binary tree and we have to convert this into a doubly linked list, that too in place. So we have given the left and the right pointers in a nodes are to be used as a previous and the next pointers respectively. Okay, to convert it into a doubly linked list. The order of the nodes in the doubly linked list must be same as the in order of the given binary tree. So we have given this as in a in order fashion. So we have to change that into a doubly linked list. So let's see with the example. So we have taken this example. So we have taken the 10, 12, 25, 30, 36, 50. Okay. So what we have done is we have to change it to the doubly linked list. So as we know, it is given in a in order fashion. So in order आपका होता है left, root and right. Okay. So first of all, let's traverse this tree. So if we want to traverse this tree, so first of all we come on the root. So this is your root. So we come on this. So we check for the left. Do we have left? Yeah, we have left. Do we have left of 12? Yeah, we have left of 12. So that is your 25. Do we have left of 25? No, we don't have anything. So we return this and put it into our doubly linked list. So we have inserted this in our doubly linked list. Okay. So after this, what we did, we go and check for the 12. So we put 12 in our doubly linked list. Then we check, do we have right? Yeah, we have right. So we put 30 into our doubly linked list. Then what we'll do, we'll go and go upwards, and we have 10. So we put that particular root in our doubly linked list. Then we go to the right. Then for this we check, do we have left? Yeah, we have left. So we have put this third, like, then we again check whether do we have left or right or not. So we don't have anything. These are pointing to null. So what we'll do, we'll put this particular 36 into our doubly linked list. Then we go upwards and we'll put this particular root into our doubly linked list. We check for the right. Do we have anything on the right? We don't have anything. So we simply return and go back, go upward. So we don't. So we totally traverse this tree. So we have made our doubly linked list. So let us see how we'll gonna do this one. So first of all, what we'll do, we'll make two pointers. That is, first is your head and second is your previous pointer. And first of all, we will point it to the null. Okay, so currently, if they are pointing to the null, what we'll do, we'll point it to our root node. So our currently root node is like when we go from 10 to 12, then 12 to 25. So after this, we don't have anything. So currently, we will be pointing to this one. So our head and previous will point to your 25. Okay, will point to this. So after this, what we gonna do? Currently, they are pointing to this. So basically, after this, what we are gonna do? Currently, previous is pointing to this 25. Will mark previous right. So previous right. So previous right will point to your root node. So this will point to your root node. Okay, this is pointing to root node. We have created this link, basically this link. Okay, and then previous rights left. So previous rights left. So this one. We are talking about this one, like this one. We are trying to create this linkage. This one. So we created that and we'll mark it to the previous. Currently, previous at this, and the root was this. So previous right means we have created this and this. Okay, these two we have created. So after this, what we'll do, we'll change our previous to the previous right. So we'll change our previous to the previous right, and we'll go from this 25 to the 12. Okay, so now previous will point to this one. Now similarly, we'll do same for the left. and for the right tree, we'll call recursion on both of them. Okay, so hope you understand this problem. So let us see code for this one. uh, so as we discussed, so we are pointing our head and previous to the null, and we have created our one flag node, one flag. Okay, so like currently when we are not pointing to anything, so what we'll do first, like when we are pointing, when our head and previous are pointing to the null, so at that time our flag will be 0. So what we'll do, we'll check whether our flag is 0. Yeah, currently our flag is 0. So what we'll do, we'll change our flag and we'll mark our head and previous to the root. So currently our root was that 25. So we'll mark that thing. Okay. So before that, currently we are doing that in a invert fashion. So first of all, we'll call our left. Then whatever this is the whole code which we are doing for the root node. Then we are calling the right word. Okay. We are calling the for the right subtree. So we have checked what we are doing for when the flag is equals to 0. That means currently when we are pointing to our uh, this 25 node, this last node. Okay. So we changed our flag and mark our head and the previous to the root, and so this fails for the else condition. Now is your f is equals to 0? No. So currently our f is equals to 1, so we come into the else condition. So what we'll do, we are going to, so we are going to make this connection, this and this. Okay, so we made this connection. So as you know, like we have to make only one connection in the recursion, and the recursion will do its job for the rest. Okay, so we made this connection and this connection, and uh, change our previous to the this next one. Okay, previous to the previous next, right. So currently what we did, mark our previous right. So we were at previous. Okay, so this was your previous. So previous right, we made this connection. Okay, then for the previous right left. So we made this connection. Previous right is this one. So its left is this one. Okay, so we made this connection to the previous one. So we change our, then after that we change our previous to the previous right. So now currently our previous is pointing to this one. So similarly our previous, after the one more iteration, it will point to this, after that this, after that this, after that this. When this fails, we'll move out of that. Then what we are gonna do, we are simply gonna return our head, because our head stores the doubly linked list. So hope you understand this solution. So if you like the video, then do share it with your friends and subscribe to the channel. Thanks.